Year 9 Mathematics Measurement Snap Quiz. Calculate the area of each of the following composite shapes. Now, to do these particular questions, what we're going to do is we simply break up the shapes into the primitive shapes that we know how to calculate the areas for, and then we solve. So for this first one here, A, I'm going to break the shape up like so. So I have two rectangles. Now, calculating the area of the two rectangles, we'll call this one A1 and we'll call this one A2. Calculating the areas, A1 is going to be simply 11 centimeters times 11 centimeters, and that's going to work out to be 121 centimeters squared. And then A2, that's going to be 6.5 times 18 take 11. So 6.5 times 18 take 11. And why is it 18 take 11? Well, have a look. The length of this total side here, that's 18, and the length of this side here is 11. So we're going to go 18 take 11, and that should be 7. Alright, so 6.5 times 7, and then putting that in my calculator. It'll come out to be 121 centimeters squared. And then the total area is going to be A1 plus A2. We'll call it AT for A total, and A total will be 121 plus 121, and that comes out to be 242 centimeters squared. Alright, first shape done. Next one, let's go, we'll partition it the same way, and we'll do it this way. So we're going to get A1 and A2. A1 is going to be simply 4 times 3, and that will come out to be 12 millimeters squared. A2, that's going to be 8 times 10, and 80 millimeters squared. And therefore the A total is going to be A1 plus A2, 12 plus 80, and that will therefore equal 92 millimeters squared. So a little bit easier than the first one. Now C, quite a little bit more going on here. We've got this shape here, and we've got this shape here. The way in which we can work it out is notice the markings. So this represents that all the markings are the same. What we've got is this one here. So we've got 1, 2, 3. They all sum to equal 15. So what we'll do is we'll call one of these markings X. So X is going to be, I should say 3X is equal to 15 millimeters. And therefore X itself is equal to 5 millimeters. Reason being there are 3 versions of, or three lengths of X going vertically like so. So just divide it by 3. Alright, so let's go A1, A2, and A3. What we're going to find is that A1 is equal to A2 is equal to, where is it? 5 times 5. And therefore that will equal 25 millimeters squared. And then we have to deal with this one here. So what we're going to get is this will come out to be, we'll call this side length here, we'll call it Z. Z is going to be 18, take away 2x. So that will be 18 take 10, and that will be 8. Therefore, A2 is equal to 8 times, and it will be 15 total tall. 8 times 15 is 120. Moving up here, we're going to get A total equals A1 plus A2 plus A3. So 25 plus 25 plus 120. And that will all equal to 170 millimeters squared. So nothing too tricky there. Going down, we're posed with some more vexing shapes. This one in D looks to be a triangle and a square, or a triangle and a rectangle of some sort. Could be a square, not sure. Actually, no, it doesn't look like a square. What we find is we'll have A1 up here, and this one will be A2 here. To solve for A1, what we're going to have is, I'll draw a diagram first. We're going to have this. That's a terrible diagram. Alright, there we go, that's better. This triangle here, the side length here is going to be 21 centimeters, and the height of the triangle is simply going to be 32 take 16, in which case it will also equal 16 centimeters. How do I know that? Well, it's this side here, take away this side here. So up here it's going to be 32 take 16. Alright, so moving on, we know that the area of a triangle is half times the base times the height. So it's half times 21 times 16. And putting that one in our calculators, it's going to come out to be 168 centimeters squared. Finding A2, we're going to go the side times the side, so 16 times 21 for our rectangle. 16 times 21 is equal to 336, and it's centimeters squared. Therefore, A total is going to be A1 plus A2, and therefore that's going to be 168 plus 336. And that comes out to be 504 centimeters squared. Alright, next shape, we've got looks to be a rectangle with a semicircle, half a circle sitting on top. So we'll call this A1 and we'll call this A2. In this instance, I'm going to go A2 first. So A2 is equal to 14 times 6. So that's going to be 84 meters squared. Alright, and now I'm going to go for the circle, and I'm going to draw a diagram on this one because it's a little bit tricky. So imagine that's a perfect half circle or semicircle. What we find is that the diameter is going to be 14 as denoted. So what we can say is that D equals 14 meters. Therefore, the radius is going to be equal to 7 meters. So the radius being this one here. And we've got half a circle. So what we're going to find is that area 1 is going to be equal to pi r squared. So we'll go pi r squared. And then remember, we're going to go for theta. So we've got this guy here, theta. In this case, theta is going to be 180. So it will be 360 in the numerator and then theta on top. So what we're going to get is 180 divided by 360 pi times 7 squared. This is going to come out to be a half, obviously it's half a circle, times pi times 49, and then calculating this we're going to get 24.5 pi meters squared. So not too bad. Putting it all together, a total is going to equal 84 plus 24.5 pi, and then if we want we can just say that's meters squared, and yeah, we'll leave it like that because it's in its most exact form. So that's as far as we're going to go. Alright, next one, we've got a really weird shape. It looks to be, I don't know what we'd call that, but if we want we can break this up, and what we find is that we've got two trapeziums. So it's going to be, where is it? Something like this guy. So this is going to be 12 centimeters. This guy is going to be 6 centimeters, and this long one here is going to be 20 centimeters. And we'll call this, of course, A1, A2. So A1 is going to simply be, remember with a trapezium, to calculate the area, you simply take the average of the two unequal sides, and then you multiply that average with the height. So in this case, we're going to go the average of 12 plus 20, multiply that by the 6. That's going to come out as 2 over 32 times 6, then that will be 16 times 6. Or breaking that up a little, we're going to go 2 times 8 times 6, and then, oops, go away, 2 times 48, and therefore 2 times 48 is equal to 96, and it's in centimeters squared. Alright, so that's the first one. The second one, I'm going to draw a diagram. Something like, that'll have to do 10 centimeters, 6 centimeters again, and then the longer side is 20 centimeters once more. Alright, so calculating area 2, we're going to do the exact same thing where the two unequal sides here and here, we're going to average those and then multiply it with the final side there. So that's going to come out to be 20 plus 10 times 6, 30 over 2 times 6. That will be 15 times 6, breaking that down into its factors. We're going to get 5 times 3 times 6. Doesn't really help, so I'll throw it in the calculator. That will come out to be 90 centimeters squared. So that's A2, that's A1. Moving down to get the total area, it's going to be 96 plus 90, and that will come out to be 186 centimeters squared. So nothing to it. This is probably about as hard as it's going to get. So take home message here is, guys, if you see a composite shape, just break it up into the shapes that you can see and then deduce it.
Shayore shukare makirude palamande makirude palamande shayore shukare makirude palamande makirude palamande Adam beklenmen çay şukariye Moci dilan çay şukariye Girindik mat şayı